We're going to look at practice 3B, which is vector resolution. And we're going to look at problems 1 through 6. Okay, so we'll do number 1 first. It says a heavy box is pulled across a wooden floor with a rope. The rope forms an angle of 60 degrees with the floor. So we want to draw a picture so we can conceptualize it. So if this was the floor, and now I have a box, and I'm pulling it with a rope, we're not taking into account like where the rope is. So we're just going to do a dot for the object. Okay, so here is the 80 Newton force. Remember, all we're doing now is we're practicing with vectors. A tension of 80 newtons is maintained in the rope. Find the horizontal and vertical components of the force. So basically we have this force and we want to find the horizontal and vertical components. So this is where I start and this is where I end. So to find the components, I either have to go horizontal or vertical. So if I start here, I'm going to go horizontally to the point where then I'm going to go up to get to my end point. So this is the horizontal component of the force, which I'll just call X. From the head of this vector, I do the tail of the other. Remember when we did vector addition? And I'll call this one the Y. This is my angle here, which is 60 degrees. So basically now you see I have a right triangle. I know the hypotenuse. I know all the angles in the triangle, so obviously I can find the other two sides. So should I do sine, cosine, tangent? You know, how do I do this? Don't skip steps. If you're not sure, write down your definition. I know sine of theta is equal to opposite over hypotenuse. So in this case, opposite is y and the hypotenuse is 80. So I can say sine of 60 is equal to opposite y over the hypotenuse 80. Therefore, y is equal to 80 newtons times the sine of 60 degrees. On my calculator, I'm going to press 60 sine times 80 equals, so it comes out to be 69.28. So I'm just going to say that y is equal to 69 newtons. Now, for the x component, I can either write my definition. Cosine theta is adjacent over hypotenuse. Then substitute in cosine of 60 degrees is equal to adjacent x over the hypotenuse 80. So x is equal to 80 times the cosine of 60 degrees. So on my calculator, 60 cosine times 80. So this comes out to be 40 newtons. Now, is that the only way to do it? Of course not. If I actually had this and this, I could use the Pythagorean theorem to find the other side. So which way should you do it? You need to do it the best way that you first need to understand it, but realize the whole point of this homework is for you to take any vector and be able to find the horizontal and vertical components of it in order for us to then go on and do projectile motion. All right, let's look at number 5. So number 5, I actually have, or you know what, I'm going to do number 6. So number 6, I have a vector like this. This is 155 newtons. And this angle here is 155 degrees. And it says find the horizontal and vertical components. So this is where I start. Remember, that's my endpoint. So first I'm going to go horizontal. From the head of this vector, I do the tail of the other. So this is my x, this is my y. The x and y components have to be perpendicular to one another. So they have to form a 90-degree angle. So the whole point here is these are supplementary angles. So obviously you want the angle in the triangle, so you just subtract. So 180 minus 155 degrees is equal to 25 degrees. So now I see that this is 25 degrees. And to find the x component is adjacent to the angle, so x is equal to 155 cosine of 25 degrees, which comes out to be 141 newtons. And then my y component, y is equal to 155 sine of 25 because the y is opposite the given angle. So then on my calculator, 25 sine times 155, this comes out to be y is 66 newtons. So again, this is just us practicing to find the horizontal and vertical components of a vector. And that's it.